Okay, so we're still short one panel member, but we'll get them added in as quickly as we can if they are able to connect in.
Yeah, I think he ought to be alone momentarily. Sorry.
No worries. As soon as he's on, if you know, poke Troy or I, and we'll get him set up as co-moderator. But what we're excited for today's topic. Today's meeting is a little bit longer than usual to try to afford us time, because we expect there'll be some good conversations, questions from everybody. We want to give time for those questions to be able to be answered. So our topic today is service models for researcher purchased computing and data, you know, a condo model kind of approach at things, but we want to be, you know, a little more abstract to that, just because, you know, things are very different for all of us at our individual institutions. We're excited. We've got a wonderful panel today of a very broad representation, I think, of different perspectives on this approach at different institutions. So on the document, if you're looking at that, just going kind of down through them, we've got Jane Combs and Kurt Roberts from University of Cincinnati. We've got Rich Nepper from Cornell, Kevin Colby from Purdue, Eric Marshall, as soon as we get him connected in, from Rutgers, Killian, and I'm going to try my best at the names, Cavalotti, and Ruth Marenshaw from Stanford. I apologize if I messed up the last name, Killian, here for us. So the way we'd like to kind of go about this today is we're going to start off with this lightning talk round, where we've asked each of these groups to kind of do a quick 5-minute-ish, you know, talk about their site and kind of introduce things. And as we have that go through, we'd kind of like to maybe encourage people to kind of hold back their questions, definitely record them. Feel free, if you'd like to put them out into the chat so that we can kind of queue up these questions. But we'd like to let the sites kind of work through their through their presentations. And then kind of as they conclude those presentations, then what we'd like to then do then is then turn it open to just an open Q&A. I'd like to kind of think that we'll be close to 11:30 to 11:40 when we're done with the lightning talks, and that will give us close to the, you know, an hour or a little bit less than an hour for just open Q&A that's really driven by what everybody else wants to bring up. When we do go through the Q&As, the way we'd like to try to make sure we have enough time to get through all the questions is instead of throwing each question at everybody, each of the sites on the panel, maybe we'd like to try to target 2 with maybe a third site responding to each one. So Troy and I will kind of help try to moderate and kind of keep things moving. But kind of with that, feel free to kind of ask questions about whatever in the chat. Or once we do get to the open Q&A, feel free to unmute yourself and throw out a question that way as well. Troy and I will try to watch the chat itself and kind of help moderate the questions there too. But with that, I will kind of turn things over to our first speaker. So for the speakers, because I think this will be a little bit news to them, we're going to go kind of in alphabetical order as far as institutions go. So Rich, that kind of puts you up first with Cornell. And then we'll follow on with Purdue after that, then Rutgers, Stanford, and then University of Cincinnati. So Rich, are you ready to go?
Yeah, I guess so. Hi, everyone. I'm Rich Nepper. I'm the Deputy Director at Center for Advanced Computing at Cornell University. My service is a little bit different than maybe some of the other ones or some of the condo models. I'm going to talk about our Red Cloud on-premise cloud service. A little introduction about our center. We're a small center. Cornell is pretty much a full cost recovery place. So we're essentially a research core that provides computational resources to researchers at Cornell. We also participate in some national grants. You can go ahead and advance the slide, please. So we set up an on-demand cloud service rather than a centralized cluster systems. If researchers are going to pay for a resource, our organization is really cloud forward. and has been looking at this for quite a while, and decided to go with this as sort of the research platform. And the reasoning behind this was researchers want control. They want to install their own software. They want to run things when they want. They want to manage the people who are using those resources, not wait for people to add users. And they wanted to be able to decide on how much resources they want to consume at a given time. They also want protection. So in terms of a cloud resource, rather than just becoming a gateway for public cloud like Amazon, which is happy to let you run and run up bills as much as you want, we wanted to provide a model that would protect researchers from cost overruns and give them some guardrails essentially to work within. We also wanted to provide a security stance that would protect them somewhat from painful mistakes or oversights that might be difficult to deal with on their level, and then on the institutional level as well. So that's sort of the reasoning behind the service. So we can go ahead to the next slide. The service is infrastructure as a service on OpenStack. The researcher can request an instance. They have full control over start, stop, and shelve. There's no oversubscription to resources. So every core in an instance is a physical core. We offer up to 28 core systems. Actually, at this point, we offer up to 56 core systems. There's a standard 8 gigs of memory per core all across the resource. And then we have GPU resources available. We're up to 20 T4s and 4 V100s at this point, trying to meet some of the interest and demand. Everything is pretty much up to the researcher. They get their project, they log into Horizon, which is the OpenStack web interface. They can start and stop. We have done some things to make networking a little bit easier, so they don't have to do the subnet creation that can be a kind of a hurdle. And then all the instances have a host-based firewall by default. So if you need to know how to enable SSH, if you want an SSH into your instance, otherwise it's completely locked down. We make sure that if people are just logging in to run code, they don't have anything that's visible on the network. This is a subscription-based model. So rather than a condo model where you buy nodes and get access to them, researchers buy a subscription, and that gives them access to the cloud. Everything is based on a core hour unit. So one core running for 1 hour. If you have a big instance, you run it 28 times faster. And a subscription is equivalent to a core year. You also get a 50 gigabyte initial storage. Additional storage past that incurs a cost that is monitored on a monthly basis. So the researcher goes into our website, they create a project, they add subscriptions to that project, and they're ready to go. Whenever an instance is running, you're burning through your subscription. When the subscription gets low, we reach out to the researcher and say, hey, would you like to add some more because you're coming to the end? At no point do we terminate instances. Well, unless something were to go for an egregiously long time, we don't terminate instances. So researchers can finish their work. They don't get booted like a spot instance might be. But we make sure that there's a balance between getting work done and having things run over. And then we have a model where if a center wants to offer their researchers a set of projects, we've done this with some student groups and the Cornell Institute for Social and Economic Research, CISR. The parent institution can buy subscriptions and allocate them to projects, and that will allow you to have multiple folks working on things at the same time. They can move back and forth between projects and use them up or pass them on to other people who need those resources. Go ahead and advance to the next slide. So this has been a really successful service for us. We've delivered over 4 million core hours last year, which is up 1 million over the previous year. Our pricing for Cornell faculty is extremely competitive versus what public cloud will cost compared to AWS reserve pricing. The comparison for GPU, even though we bill them at the core rate, so if you're using a GPU system, I think you get billed at 14 times because you're using 14 cores. it's still well over 50% discount for GPU. Researchers also like that there's no queues. We've had people who have moved research over and they're able to get things done much faster, not because the compute is particularly faster, but because they're not waiting a week in a queue to get their jobs to execute. And so we have some really nice research stories from that. We follow utilization to expand. So our systems director keeps an eye on things. And if we have about 80% utilization, she goes ahead and brings more nodes into the service. So we're sort of constantly staying ahead. We have headroom. The other thing that's really nice is this year, we've put together, as I said, this agreement with Sizer. They get all their compute through CAC, and we've also created a new agreement with the Johnson College of Business at Cornell. It was sort of based off of startup negotiations where one researcher was coming in and wanted a startup package that we, over time, explained how he could get it done in Red Cloud, and the dean decided he wanted to create sort of an overall project for College of Business faculty to take on, and they bought 1.8 million core hours for the startup and an additional 500,000 core hours for the researcher. So it's been a really nice arrangement where the college is arranging to get resources for professors there and provide that to make use of them. That's the overview. I'm happy to answer questions. I know there's been some in chat as I've been rattling through this. Are we doing questions right now, or wait until we get through?
Let's hold questions till we finish the lightnings, and then we'll jump into questions.
Sounds good. All right.
All right. So our next presentation will be from Purdue. Kevin, are you ready to go?
Yeah. Can you hear me?
Yep.
Good. Hi, I'm Kevin Colby. I manage the research support team at Purdue University. We're part of the research computing organization, supporting researchers across the Purdue system. I've been with the organization various roles since we first launched some of our first clusters in the shared model back in 2004. We would later turn this community cluster. That effort was very quickly a huge success, so much so we were able to build a program launching a new major system every single year thereafter to present. So we've operated each system for about 5 years. So unlike many in this space, we usually have a number of concurrent major systems of overlapping age that we're running. And you can see some of the overall figures for the program on the slide here. All these started with the same set of basic structures though. Okay, next slide. And we wanted to offer access to systems that was proportional to the faculty investment. It was critical for us to remove IT or central administration as some sort of de facto judge of your science worthiness. So we worked hard with faculty to incorporate funding into their grants, just as they would for wet lab equipment, such as a microscope. So the worth of their effort is judged by their scientific peers alone. And they also use a lot of times startup funds and things like that. That said, the university is a full partner in this and subsidizes about 50% of the total cost of the system. We pitch this as pay for the nodes you need, and we'll cover all the facilities, power, cooling, networking, storage, expertise, and support. Just to drive home the comparison a little better than some arbitrary 50% percentage, in case any of them were considering building their own. Moreover, we stress how tasking grad students with managing a cluster never delivers what you paid for, and would be a waste of the students' time and skill. The biggest factor, though, is just winning over a few faculty in each department. Word of mouth within departments by faculty was and absolutely remains the best way for us to gain new customers. You can see some of the details on this on slide for all these things. One aspect, a little bit more unique to our approach, was to focus on real-time system use and not grant allocations. So we don't do any grant allocations. This incentivizes users to spread their own usage out over time and avoid having traffic jams when everybody needs a system at the same time. Because no matter what the reason, if that happens, we'd inevitably be viewed as not delivering the service that was paid for. So our real-time usage approach includes dedicated queues for each customer rather than queues structured around job parameters. So this let us offer priority access proportional to each customer's investment, guaranteed within 4 hours at all times. And standby access to the entire cluster for any jobs less than 4 hours was a huge selling point. The gains from just buying your foot in the door were significant, and this drove a lot of adoption from faculty who might have otherwise held back. Once they're in, they're enjoying the service, all their codes are working smoothly, of course, it's a lot easier to sell some additional nodes. We also work closely with the Sponsored Programs Office to ensure our services could be used for grant equipment purchase funds. This cleared a lot of major hurdles for faculty with their grants and allowing funds to be used to purchase into the shared systems. So having your Sponsored Programs Office on board, we really think is critical to success here. Next slide, please. In 2015, we pivoted slightly to better address some underserved segments of the market. We launched multiple concurrent major systems, so we could dedicate some to specific communities who needed more specialized or expensive hardware options. We'd always offer these as smaller segments in our larger systems, but because of the small size of the sub-communities, they found their investments were isolated by the annual build cycle. So the benefits of standby were largely unavailable to them because they didn't have hardware needs that were in most of the nodes, and it was hard for them to share with their actual peers because they might be separated by being in the prior year system or next year's system. And so we just kind of restructured that a little. And this also started a general opening up process, I think, to designing various systems with different communities in mind and employing different funding and operational models for those different communities. The first and largest of these was the high memory community, because they usually needed 2 to 3 times the amount of memory that mainline HPC users needed. And one of the things we found is openly and directly marketing to the community and not just leaving them as an upgrade option to something else made a world of difference. There was so much demand beyond expectations. We actually outstripped the networking design for that system twice. We also launched the system focused on lighter weight traditional interactive use without a scheduler. We usually say less than a research cluster, but more than your laptop. For it, we went with a simple flat rate annual subscription model, no performance guarantees, because those users, consistent runtime, predictable scheduling don't matter to them as much as just a low price of entry. So we've done a GPU-focused system in a similar manner, and Purdue's been a leader in the CUI space. We're now in our 2nd generation of approach to that more mirrors the mainline research cluster for a funding model. All that said, this year we're folding our high memory users back in with our mainline HPC system users because the economics around processors has changed. Due to increasing density, the per node memory has effectively climbed compared to the processor cost. So these communities are better able to share same physical node configurations, and rejoining will now give both groups more. So one thing I'd say is overall, it's essential to be flexible and ready to shift all of these things to suit changing communities, changing economics, changing technologies, and don't be afraid to reevaluate your own rules and listen to your customers. They don't always know how to articulate what they want, but if you listen, you can figure it out. Thanks.
Okay. So our next institution is Rutgers University. Eric, are you ready?
Yeah. So I'm going to actually forgo slides. So where to start? First, I'm the Director for Advanced Cyber Infrastructure for Rutgers University. I work in the Office of Advanced Research Computing. My background in HPC comes from working within the government. I used to work at the Geophysical Fluid Dynamics Laboratory and managed about half a dozen of their HPC machines clusters there. In that environment, HPC was kind of a different beast than I found at Rutgers, in the sense that climate prediction models were really the only thing they were running, so you'd build a system to match that application. When you were buying a box, you'd say, how many cycles can we get of this particular app compared to somebody else's stuff? In Rutgers, that model doesn't quite hold. It's a much more general purpose system. Before I kind of start talking about that, I want to do a little bit of history. So I was at Rutgers almost 15 years ago now, that the first idea to try to pull together and collectivize and come up with a HPC strategy was put in place. And it failed, to be honest. So I want to talk about that a little bit to kind of describe why that failure happened. So as a cautionary tale, some may pick up some wisdom from that. There had been an attempt previous to me getting there, and that had gone south because there wasn't an equitable way to share who got what. And eventually it fell apart. The biggest users pulled the parts of the system to their own use, hogged stuff essentially, and stole key personnel, allowing them to set up their own little fiefdoms, their own little clusters. The funding model at that point made it completely possible, and by the time I came on the scene, that bad taste for those who didn't get anything out of that was still present, and those who had kind of come out on top of that, they were quite happy with the current system and just wanted more resources if they could get it. There was no subsidy. There was no way to ensure equity. There was no way to ensure growth. That is, how you're going to refresh the hardware. And there was no way to kind of vet who would be able to do what if you don't have a way to equitably share the machine. So the goal of having something for people with no money versus folks with lots of money really didn't pan out. I tried to follow the model that Princeton University had at that time, which is essentially a condo model. And without support from the central government, central management, there was no reason for a researcher to buy in. If they could run it themselves, they could do it more efficiently and customized to the applications they wanted to run, and could buy hardware at the same price. So that was kind of a number of the reasons why things failed. And there's also some institutional aspects of how money flowed that also kept it in the best interest of a PI to be on top of that instead of trying to share resources. So fast forward, 5 years ago, OARC, the Office of Advanced Research Computing, roughly speaking, it was created. In that iteration, at that point, Rutgers had just eaten or merged with a medical school, and so their HPC team and Rutgers were merged together. In the New World Order, there was a more equitable way to share stuff. There was financial support from Rutgers proper, so that you could then essentially subsidize the funding of things. So if a researcher had to make apples to apples comparison, a centralized solution was cheaper. That was who's going to argue against that? We also had a nice innovation that I did not have in any other places I worked. That is, there's technical staff, your sysadmins, programmers, that kind of stuff are in one team. And then there's another team called ACI refs. These people are essentially help desk on steroids. They're PhD folks, they're published work, they're researchers, they're part of grants, and they're the people who are making sure that the folks using the system are efficient. They can get their work done. If they stumble on something, those people can jump in, tweak something, and make that stuff just zing. So that frontline expertise, frees up the sysadmins to do more nuts and bolts work, but it also means the scientists are talking to scientists about the same topic, so there's no vocabulary issues, and the knowledge on the applications is much deeper. You may have that in a classic HPC setting where you're just doing one type of applications, but at Rutgers, where we're doing essentially general purpose, all things to all people, less of an issue. I should also back up and say that OR covers, it's almost like a skunk works for anything that's going on. So we have people help you with grants. If there's some bit of infrastructure that Rutgers doesn't have that would allow your grant to go forward, we can pitch in and be part of that grant to help write that grant. We also are the gateway for research use for access to cloud infrastructure. So we have legal agreements in place with Google, AWS, Azure, that allow us to do single sign-on, to do some of the plumbing and routing for billing, and give Central IT a little bit of confidence that we can shut something down that may have gone rogue. But it also means that we can now essentially be a conduit to resources within, say, Google or Amazon that a researcher may not have on their own. So if there's some particular weird thing you want to try and you're getting stuck, we can reach into Google and say, hey, can you help us out with that? So that lowers the barrier for people getting to the cloud stuff. But we also take care of the mundane stuff. Like, I'm a researcher, I'm too busy, I don't know how to add these people to my group, just make it so. We can handle that as well. We've also support data science. Up until about a year and a half ago, we had a big Hadoop cluster, big data Hadoop cluster. We're currently working on OpenStack so we can hand out VMs. We're working with the central IT group to come up with a data warehouse that will support personally identifiable information. So there's a bunch of other things that's just it's just a thin slice of all that crap that's going on. We also have ingested old clusters, which I lovingly refer to as our hospice program. So if a researcher is having a hard time coming into the fold to join the collective cluster, which is called Amaral, we'll help them with their old cluster so they can transition. And so that's been successful in the sense that people have jumped on that and given us their old systems. Less successful because then we get their old systems and have to deal with that until we can kill it off. Yeah, I say we're welcome to use the phrase hospice. I guess the more polite one is legacy, but really we are just waiting for them to die. So back to our current setup of the cluster. So the big cluster that we have two large clusters. One is called Calburn. It's a former top 500. It uses the model of people applying for allocations or grants of time. And we inherited that system and we still abide by that. The other system is Amaral. Amaral is a slightly unusual in the sense that it is a condo cluster, but is also a cluster that allows us to harvest the free cycles. So anybody at Rutgers, that is if you're faculty, staff, or student, and you want an account on Amaral, you can. There's no cost. You can show up. The price you pay is being preempted. So we set up Slurm, that's our scheduler for that, that if you're an owner, you get essentially premium access and you'll bump people off of the nodes that are allocated to you. The goal we have for the cluster is as clear as we can make it. We want it to be like you own the cluster yourself. It was like under your desk in the lab. Obviously, we can't do that completely, but at the end of the 4-year period of your purchase, if you want to take that node back to your office and use it as a paperweight, you're welcome to do so. The compromises we make in that sense of trying to make it as much as like an owner can is that we do have a common scheduler. We do have a kind of a gateway through these refs I mentioned before in terms of installing some software. There's also a community path where you can install your own stuff either in your home directory or in a communal directory. So if you do the work once, everybody in your group can share that, or anyone across the system who can make use of that. So our AC refs will make that software available to everybody, or if they'll build something they think is useful, and if it doesn't go through the full vetting process to be part of the standard stuff, it can exist in these community locations. I would also mention that, I'm sorry, let me sit here. Should also mention that in that condo model, you'll buy the node for 4 years. You'll get 1 terabyte of data as part of that buy-in package. You can buy more. We've had discussions about how to handle larger purchases, but essentially you can buy more storage if you wish. We set that up as you have a home directory of about 150 gigs, and then you have project space, which is the terabyte or more, and then we have a scratch directory, which we flush every so often. Within that model, I'd also add, currently we experimented with having the allocations float either by processors, how many processors do you own, versus actually tied to a node. And due to some of the quirks and nuances in Slurm, we're currently still tied to the per node. I should also mention, unusual to our cluster, unlike everybody else's, Rutgers is large. It's distributed across the state of New Jersey, like many state universities. And so we actually have a cluster in Newark, which is in the north end, across the river from Manhattan. We have one in Camden, which is across the river from Philadelphia, and then one on the main campus in Piscataway, which is halfway in the middle. So it's like a 90-mile run between all the bits and pieces. That shares a common file system from the user's point of view. We are a GPFS shop, and we use the AFM mechanism to cache across so that you can run work in Newark, or you can run in Camden, or you can run in Piscataway without too much heartache. We've tried the federation mechanism through Slurm, so that's in place for part of the cluster, and we've also tried multi-cluster, so that's part of the other chunk. So those mechanisms are in play, and we've been going back and forth with Slurm to tweak that. There's a mechanism that we've experimented with to pass jobs through our scheduler into the cloud. So if a researcher receives credits from Google, but they like using our setup, they can just submit to us and we'll pitch it to the cloud. What else is kind of fun about that stuff? We have 100 gig backbone across the 3 campuses, so we can make sure that the performance of the file system isn't too crazy. We use kind of a generational model of some other places I work will have one HPC cluster, and look at that stable on one. That is starting to be too long in the tooth. Let's have a second cluster, and then once this is stable, you move everybody off and you kill off the first one. We just keep bolting on, so it makes it a little trickier for us to do things in production, essentially, to continue to grow and update stuff. But on the other hand, it means that all that stuff is available to our users. So we don't have scheduled downtime. Some shops will have 1 day a month or 1 weekend a month or something like that. We just take it when we need it. So recently we had a teaching cluster where we wouldn't touch it during the semester. So those nodes would be updated at the very beginning of a semester, stay stable, and at the end, we'd refresh that.
Eric,
sir,
we need to keep room for the other 2 sites as well.
My apologies. So I'll take questions at the end. Thanks.
Yep. So our next site present is Stanford. And we have Ruth Marenshaw and Killian Cavalotti. And Ruth and Killian, are you both ready?
We are, and we're going to tag team this presentation. We know when we're going to each talk, I believe, so hopefully that'll work out. And it's wonderful to have the opportunity to do a lightning talk, so we're going to talk very fast, and then we're happy to have questions. It's also great to see, as I look at the participants, so many people I know, but even more that I don't know. So I'm delighted at how the community has flourished, and appreciate CARC growing the people network. So next slide. We're going to talk about Sherlock, which is our shared campus HPC cluster. Stanford, like many private universities and some publics, there's virtually nothing centralized, and there's no mandate that anyone use any technology platform. But this is an opportunity, and it's available to any researcher at Stanford to use for their research. This is not a teaching cluster. It's available at no cost in terms of accessing a shared pool of resources, but that's a limited shared pool of resources. So we do offer and primarily rely on a typical condo model where PIs may choose to become owners by purchasing equipment. And when you become an owner, you get your own Slurm partition, similar to what was described at another site. If you want to use your resource that you purchased, you get priority. Anything running there already will get killed and re-queued. So next slide. We've been in operation with this model for 6 years. We've been in existence for almost 8 years. We had to have a data center before we could put equipment in before we could start this model, and it has been quite successful, as you can see from this not very good graph. We can work on making it more legible for the final version of this presentation, but 18x growth over the 6 years. And almost all of that is in the form of PI purchased servers. So now next slide, and Killian's going to take it.
Yep. So as Bruce mentioned, the cluster is changing on a very regular basis, where we add nodes that are purchased by PIs and research groups. So right now it's about 1,400 compute nodes, and we have various generation of CPUs, different ratios of memory per core. Now we also have different brands of CPUs, different manufacturers. We introduced a 3rd generation of Sherlock yesterday with AMD CPU. So it's a brand new adventure somehow. We have a number of GPUs. So I think totally we have about 30,000 cores in the cluster right now, and that's spread over 3 different IB fabrics from different generations with different characteristics as well. So it's a lot of different things that need to be interacting with each other and kept as a homogeneous entity somehow for the users. So the user-facing side is that we try to make it as simple as possible with one name for people to log in. They can SSH to a single host name, and that's a pool of login names that are distributed across the different parts of the cluster. And they can access the same set of software across all the nodes. They have, we try to make the experience as seamless as possible for most of the users, and that's sufficient for what they want to do. And the users who have more advanced needs, we provide them with tools and ways to request exactly the specific resources they need for their computation. We're running Slurm, so we can create partitions for the different groups that purchase nodes. And that's been very successful. Next slide, please. In terms of funding model, we have a base infrastructure and a set of freely available resources, as was mentioned, that is available to everyone at Stanford for research, and that's funded by the provost. That's central funding. It's refreshed every 3 years on average, and that funds the shared server, all the services that we need, the login node, the management infrastructure, the Ethernet network, the PDUs, racks, and so on. And the InfiniBand infrastructure as well. For the owners, for the research group that want to buy their own resources, they actually pay for the equipment itself, the compute node. So we have a catalog of configuration that they can choose from. And we also ask for a participation for the infrastructure, for the InfiniBand cables, the switches that we need to add to each rack to make the cluster. So that's a modest contribution to the infrastructure. And the model that the owners get immediate access to the resources they purchase, so they don't have to wait in queue with anybody else other than the people from their group. And they can also access all the other owners' machines on the cluster when they're not in use. So we have a preemption model. All the jobs can run in background, and when the actual owner of the machine needs to run job, the background jobs are preempted and requeued somewhere else. So about 800 PI groups are participating in Sherlock right now. They have access to the cluster, and 157 out of them are decided to purchase nodes. I think the next slide is about policies, and Bruce will talk about them. Oh no, that's the purchasing model. Sorry, I missed that slide. So the purchase can be done at any time. There's no timeline or no regrouping of purchases. So we negotiate prices with the vendors so we can get the best price for the researchers. It's some challenge sometimes because not all vendors really understand volume of purchase over time. They're more used to people buying a large amount of equipment at once. And we don't really work that way. We can buy one server every week for months. So it's a different model basically. So we do all the purchasing process for the PI. They just decide how many nodes they want, and we do the purchasing for them. There's no limit on the number of nodes they can purchase. So it's from 1 to the maximum we've seen so far is 172. So depending on the groups, some groups are smaller, some research groups are larger, some are like almost at the institution level. They have some institutes within Stanford that do group purchases for them. We will also start seeing school wanting to purchase resources. So over time, the evolution of the whole cluster is a bit complex because we get quite a number of different server types and servers with different characteristics. So it's a challenge to keep that working as a single entity. But I mean, it's been very popular in the fact that it was flexible for the researchers, so they could really get the resources they needed anytime they wanted. So I haven't mentioned, but the nodes are purchased for a duration of 4 years so far. It has been a challenge for some users who don't really have the need of resources for that long of duration and would like some more flexible options. So we're working on trying to make a leasing or subscription model ready for them, so they could just get some resources with some kind of dedicated access that the actual owners have, but on a shorter timelines. So it's coming, hopefully. Next slide is about the policies.
Okay, so quickly, policies. We do, it's not reflected here, but we do have a faculty advisory committee comprising large and small users of this resource, owners and non-owners, to help advise on these policies. But any PI on campus can use that centrally funded small pool of resources, as long as their data aren't what Stanford considers high risk. We have a separate environment that's not a condo model, so we're not talking about it here today, for high risk data. We organize on the basis of the PI, and if you look at the chat, you'll see how we differentiate. This is really for faculty, but faculty who are PIs, most are the same, but there are some School of Medicine clinical faculty who don't have PI status. So like everything at Stanford, it's complicated, but in essence, we organize on the basis of PI, and the PIs get accounts and they request accounts for their team members. Because we are part of the university, we do have to follow our university security policies, and those policies require a quarterly review of accounts. So our PIs quarterly review and send back information on who might have left their group, who might have left Stanford, who might have changed resources, and Killian manages that. We have very generic slurm controls on the normal shared anybody can use partition, but the PI owners, they have a lot more flexibility on their slurm scheduling parameters because needs are different. Owners can buy, again, as we said, in and can use what they purchased whenever they want, but they can also leverage the big pool of other owner resources, subject to immediate termination if an owner wants to use it. Requeue is needed. And there was a question to help us think about what to present about your operating policies. We are not a 7x24 shop, and we make that clear to folks. If the whole cluster is down, or the file system has issues, or there's some issue that affects a majority of the cluster, of course, Killian is on call and available all the time and jumps in, and our storage admin. This is really very leanly staffed. We have Killian, we have a storage admin whose salary is fully cost recovered by our non-scratch storage. That's a different topic. Again, not really a condo model. And then we have about a total of two FTE for support tickets, plus of course the sysadmins take that. Next slide. Next slide. And these are just pretty pictures because I want to throw them in. Killian and Stefan, the storage admin, monitor the heck out of the system and using Grafana and some beautiful graphs that if we were able to work in the office, they have this gigantic screen in the office where they can keep a visual eye on what's going on. And next slide is just another pretty picture. And then that's the end of our presentation. Happy to take questions at the end or in chat. And thank you for the opportunity.
All right, thank you. Our last panel site is University of Cincinnati, where we have Jane Combs and Kurt Roberts. Jane and Kurt, you ready?
Yep. All right, so hello everyone, I'm Jane Combs and I'm the interim director for our advanced research computing facility that we're developing. And Kurt Roberts is gonna participate in helping explain some of the things that we're figuring out as we go along here. Next slide. Can I change the slides? No, you have to change slides. So UC's Advanced Research Computing Facility is an emerging center. This has been in progress for about 1.5 years. you know, we've been thinking about it for a lot longer than that, but we actually got a pilot going back in January of 2019. That was, the costs of it were covered by an MOU between IT at UC, which is where the cluster resides, organizationally, the Office of Research, and a chair of our faculty advisory committee, Dr. Prashant Kare, who came to UC with 20 nodes in his startup package and wanted to put them as part of a central cluster, which we didn't have. So the Office of Research agreed to, at that time, provide 50% more nodes for him if he would make that shared. So we did a really good pilot and found out that yes, indeed, there was interest, because there was concern from our institution that people would not be interested in using something like this. So we, in the first 6 months, we had about 84 faculty researchers who used the system from 9 different departments, and we had about 70 different graduate students using it for their research and for their education. This year, because of COVID, we thought we were going to go into a production environment. We ended up having to extend the MOU. So as of right now, IT at UC and our Office of Research are still supporting very minimal operating costs, and I'll talk about that in a minute. We also have had an investment by IT at UC for some additional nodes to start a second cluster with InfiniBand. We were using OmniPath for a hot second and moved off of that. And then we are getting we received an NSF MRI award recently, where we're going to be purchasing compute and storage, which we did not have in the past. This is our first year that we've actually had faculty interested in purchasing and becoming owners of part of the cluster. This has been in response to the Office of Research. Our VPR has offered to pay for, if a faculty researcher comes on board as part of their startup package, if they're asking for any sort of HPC resources, he will cover 100% of the request if they join the ARC, and he will only cover 25% if they decide to put their equipment under their desk. Yeah, so that's very helpful for us. The VPR also stated that he will give us an additional 50% of the money to be used as we see fit. So that's been kind of a good carrot. It was not seen, you know, it was kind of, was not favorable for a couple of people that felt like we were taking away from the researchers, but we see it as really adding to their ability. Starting in fiscal year 22, which is in July 21, we are working to develop a develop the center as a core research facility. And this will have attached to it a service center, so a cost recovery model. It's highly subsidized. We can put in what rates we want to charge, which are very comparable to other places, and people will have an ability to have free usage up to a certain amount. So that's how we are planning to. We haven't done the final negotiations, but that's our plan for how we will be supporting the ongoing maintenance costs and operations. Next slide. So you can see here, we're very small, and we have big plans to be in the next 8 years to have 1,000 nodes, but we're going there kind of patiently. We're so small that we haven't even named any of our clusters because they haven't risen to that level yet. But we are working on it. And you can see that by the end of this year, we will have 2 small clusters. One is the ARC pilot, which has 37 nodes, and then ARC 2, which includes the MRI award, will have 78. Next slide. So because we are still developing, and because we have not enough hardware to provide to everybody, and because we have very limited resources. And when I say limited, I'm 50%, our Kurt Roberts, who's our systems manager, is 20%. And we have a facilitator position that's 20%. I mean, we're not even full-time. So we are very limited. We're planning, you know, as we go forward and with the service center, and now that we've convinced everybody that this is needed, but we decided to do it the hard way that everybody told us not to. Well, they said, whatever you do, don't get the equipment first and then try to get the positions. But I think in my experience with other people, this is what tends to happen. So when we started looking this year, just really in the last couple of months at these startup packages, purchases, we looked at different ownership models, you know, for condos, which you've heard previously. And we decided that because of our limited staff and resources, we needed to be maybe a little more creative. So we have not finalized this yet, and Kurt and I joked at the beginning of the week that we have to come up with, before we can make the slides for this talk, we need to come up with what we're going to do, and we still haven't finalized it. We're hoping for input from this community to give us, you know, to learn your lessons and to help us do what we need to do. So we evaluated the ARC team, which is us internally. Of course, we wanted the ownership model to just be, everybody has access to everything they need, an abundance of resources, similar to IU, but you know, the issue there is there's no golden goose. Nobody has done that yet. Nobody's said we can have 12 people that can support all kinds of things. So the faculty chair who donated his equipment, his plan for ownership was that owners would have specific nodes that they purchased, that we purchased for them, and then added it to the cluster, and the actual piece of hardware they would own and be added. The issues that we saw with that was that the staff would have to manage individual nodes instead of the whole cluster. So, you know, instead of looking at nodes as cattle, they'd be more like pets. And that's thank you to George Turner, who from IU, who has shared his knowledge with us and helped us understand that. One thing that does is it requires a commitment to the owners about availability and uptime of their resources and responses to incidents. So, you know, you're ending up with a bunch of individual clusters really that are all connected together support-wise. And we just didn't feel like with the limited staff, and especially now with COVID and where we're at, that we want to take on that. Need to have backup nodes, which was the suggestion of our faculty chair, available to replace condo nodes if they go down. We know we don't have any extra hardware, and we don't really have any way to purchase extra hardware to have backup nodes sitting and waiting. It requires individual queues for scheduling, which again, complexity, we're trying to keep things simple. Difficult backfilling unused available condo resources without using preemption, which a couple of people have talked about preemption. We did that during our pilot, and people were very unhappy about preemption. So we'd like to avoid that if we can. And it can result in a heterogeneous cluster if researchers are able to choose their own equipment. So we have kind of come up with a compromise, and the slice was one of the options that the coordinators here suggested. And so we buy into a portion of the cluster for the life of the cluster, and then implement job priority boost mechanism via SLRM to provide enhanced access to the cluster computational resources proportional to the customer's contribution. Kurt's going to talk a little bit more about that and how we think that that's going to work for us. So you can go to the next slide. That decision makes the funding and purchase model a little simpler. So we will be pooling funds, and we've already gotten some funds, and we're getting ready to make a purchase. We'll use the funding to expand the customer, But again, the faculty member does not own a piece of hardware. They don't own node number 12 and 13. One of the questions that we are kicking around is if a researcher wants to buy into a cluster, we think this may be an advantage to doing it this way. If it's in the middle of our, say, 5-year purchase cycle, can they, instead of buying the older equipment, and then if they're in the middle, so say it's year 3, and then when the new cluster comes on board, they'll still be stuck with the older equipment. Can they then have some of their fair share boost priority extend into the next cluster so they have access to the new equipment, which is one of the things that we have talked about with our faculty. One of the benefits for using our central cluster is that you always have access to newer equipment. Next slide, please. So policies, we want to keep it simple. Like I said, what commitments are made to owners. The cluster is supported on a best effort basis. We're not an enterprise unit like what other people have talked about. We have scheduled maintenance windows and we notify people. Individual node failures are not as big of a problem as long as, if you don't have that node is not assigned to Professor X. So we think that can solve one of those problems. Another question was when condo resources are not tied up with the owner, again, are they accessible? They are, but really this is kind of a non-applicable because condo resources are fair share boost, not actually pieces of hardware. So that kind of takes away that piece of it. I should say in this also that if you're not a condo, if you don't have priority, you get fair share. So it's using the SLRM fair share model. So everybody right now has access to use it and with fair share appropriation as it runs in SLRM. Next slide. So Kurt Roberts, our system manager, is going to talk about a little bit about what we're thinking about for job priority using the fair share and the boosting. And we'll be happy to discuss. And if anybody has any input at the end, we'd love to hear it. Go ahead, Kurt.
Hi, everyone. I hope you can hear me. We're going to very briefly go over manipulating job priority for money. As you can maybe kind of read, that's just the SLRM, the way SLRM processes calculates job priority on the right-hand side there. But so there's many factors that influence job priority. Some of them are age, fair share, job size, partition, QoS, etc. Something that's important to think about is fair share is not a fixed allotment of CPU time. You can kind of think of it as a boost that can help prioritize queued jobs. I kind of think of this as like the fast pass line, at an amusement park or something. You kind of get to cut the line, and depending on how much money you've contributed, you get to cut the line farther. Also, a low fair share factor will not shut off a user's access. Their jobs will just merely fill idle resources. Next slide, please. So this is our proposed funding model to our faculty advisory committee. It's a fair share priority boost. So we propose to increase the fair share factor in a ratio equal to the funds that they have committed. And SLRM's fair tree will fairly easily let us trickle these priority boosts down to the faculty, staff, and students. Best summarized, I think, by our good friend George. In short, until the fair share component is used up, the jobs that are able to charge to a fair share account will have a priority boost added to jobs calculated dispatch priority. Once that fair share is used up, the fair share equals 0, and they are scheduled as an equal peer to users that do not have a fair share benefit. And I think that's it.
Great. Thank you. So we have close to a half hour left, and there have been a number of questions asked so far in the chat. but our panelists have been doing a good job answering. So what I'm going to do is, instead of assuming some of these questions need to be resurfaced, if you've asked a question in the chat that you didn't get the answer you're after, I'd ask you to resurface it. But really, it's now open for anybody to throw out questions. What we'd like to do from our panel sites is kind of say, especially due to the time, let's kind of limit things to just a couple sides responding to each question and kind of rotate around so each side can have some turns answering questions.
Can we ask questions over the audio?
Absolutely. Feel free to unmute yourself.
So I have this question. So the tail end of users is very large for research computing. So how are the various computing centers trying to reach or enable that population? What policies in particular are you trying to implement so that those researchers are enabled?
Which population?
The tail end of research computing, basically users who don't use a whole lot of computing, but they have small projects that they need computing for.
Yeah. So at Stanford, we have 1/2 of an FTE funded by the School of Humanities and Sciences, where a lot of those long tail researchers reside. He helps consult and work with them. But in terms of interfaces, we do support on demand, and that's very attractive to many of those users.
Yeah, if I can add on that, we also have on demand, and we offer thin link and some other more graphical avenues of access. But one of the reasons we launched our light sort of data workbench offering was specifically targeting those users where they don't even want to use a scheduler. There is no scheduler. We just throw things out there and say, you know, you get sort of whatever concurrent use of the system will allow you to get. And they're very happy with that. But it gets them used to some of the concepts and some of the places and whatnot, so that moving to a more research cluster with the scheduler is a little bit less of a step from there.
Thank you.
From the Cornell side, we're pretty much set up to handle long tail because we have graphical interfaces based on the environment. You can get Windows instances if you want. You can use a single core instance. So we've really tried to fit it and make it useful for those types of researchers.
For the record, I'd say really quick. All the things are discussed. We're doing the same thing. We also have workshops open to all, so people can come with their questions. We've had workshops on specific domains. And then for a while, we had a person just canvassing, looking for people who might be unusual users. Like we have folks from archaeology now using the cluster.
So there was a question that was added into the Google Doc that says, for those who have converted from condo models, i.e. equipment funding, to a consumption model, dollars per node hour, how do you deal with PIs that had equipment funding in their pipelines? So let's see if there's one or two sites that want to tackle that.
I'll say from the Cornell side, the way that we've dealt with that is we have another service, which is that PIs maintain ownership of their hardware, and CAC runs it for them, and it's based on a sliding scale. So the more nodes, the cheaper it gets per node to maintain them. The PI retains the ownership and has complete control, and our folks just make sure it's up to date and safe and secure. So we've successfully done that with faculty who have moved on or otherwise have things coming in or brought stuff with them.
Anybody else want to add to that? Okay, so there was another question in the Google Doc of, do you offer low priority computing, say 50% of the standard access rate?
As I mentioned before, for Rutgers, the lowest tier is free, as long as you don't mind being bumped. So, yes.
Same at the University of Cincinnati. We're hoping everything will be, I mean, we're planning to keep free options, but yeah, you will not have a large share of or an additional priority boost.
It's somewhat similar to the question that was in the chat by someone at UC Santa Barbara. We have people that buy in for the minimum amount and then use standby extensively. And that effectively is where those people land.
So can I ask a question? So that means that you are doing, or you're doing unlimited allocations to PIs? If this is free resources, they can use as much as they want?
For record. So for us, no, they buy essentially a node's worth of CPUs. And so they're constrained to that. If they want to submit to the free tier beyond that, they're welcome to. But we also use free share as described by some of the other applications.
Anybody else a different answer?
Well, we are right now. Everybody can submit and they can run as much as they want while we're in our pilot mode. And maybe Kurt can explain a little bit about the fair share scheduling in Slurm. But you know, basically, my understanding that if they have run a job recently, then they have a lower fair share. You know, so it takes into account you can't keep running job after job after job. You get a different priority if you run a really long job and you want to run a short job. So you can do backfilling, but that's taken care of through the Slurm scheduler.
Yeah, and our proposed fair share factor changing, where we're manipulating that depending on how much money they put in. The free tier would basically be the 0, and then the more money that you contribute to the cluster, you would get a higher fair share.
We actually cap usage for the paid to your investment level. So there's no allocation limit, but there's a limit on concurrent use.
I got a question just on, like, from a storage model. How do you guys regulate how much storage the people can use? Because it seems very compute centric, and a lot of us are like genome sequences and so on. We try and have somewhat of a chargeback model just as a defer from infinite, because when we had nothing, everybody wanted the world, and we're just like, we can't even purchase that all now, and so on. And how do you guys do, like, any kind, do you do any kind of archiving to move it off and so on? I'm not trying to sidetrack the conversation, but that for us is a lot of the compute is okay, but storage is kind of all over the place. You know, what do we subsidize? What don't we? How do we back it up, and how often? And how do we factor all those costs in to the funding model that they ask? The users don't even, you don't know how many times I've heard a hard drive down the street at a store is X amount of dollars. Why do I have to pay so much? I'm sure you guys hear the same thing, and I'm like, okay. I'm just curious as how you guys are doing it.
Killian, do you want to weigh in real quick?
Yeah, I can come in on that. At Stanford, on the Sherlock cluster, we have different tiers of storage, or different storage location. We have a home directory that's using an island system, so it's very expensive, it's small, it's not very performant, so we limit that at very small quota for all the users. They also have a group home where they can share data within their own PI group if they want to share codes, data sets, smallish things. Then we have a high-performance cluster file system that is used as Scratch. This one also has been funded by the provost, so it's shared by everyone. We have largish quotas. Each users can get 100 terabytes. But then the file system is purged. The files have a 90 days retention period, so that's how we keep things manageable. It's really temporary storage, it's high performance, but not for long-term storage. For long-term storage, we have another option, which is pay for what you want to use. It's also based on Lustre. It's accessible on the cluster the same way as a Scratch file system, except is less performant. And it's really designed for volume. So we offer chunks. Well, we don't offer. We offer for free. PIs can purchase chunks of 10 terabytes and even now 250 terabytes at once, and they can grow over time as much as they want. It's almost infinitely expandable. There's no purge or no retention or anything. The data is here to stay forever, and that's how they manage the different storage needs they have. Fast storage for the temporary stuff and long-term storage that they can expand as much as they want.
Yeah, we do almost the exact same thing in that we have scratch storages and things like that that are tied to the clusters. And so that's part of the clusters funding model and how that's paid for. But we also offer a permanent long-term storage that you can pay for per terabyte, and it's just as much as you want. And then we have a free archive too, just tape archive. But the long-term stuff, yeah, we charge for the same as basically for a cluster.
And do the users themselves, do you have them do the data movement, or does some automated process do the data movement for them? Because we're finding it very manual for some stuff that we're doing, and we'd like to automate it, but we've yet to find anything that like is good, or just how they work is all scattered. We can't find a tool to automate it because their data's in like 12 different places. And what's, you know, if it was project based, that would be great. This project, boom, but it's, you know, it's not. So that's what I'm curious on too.
Well, a lot of our things are project based in the sense that the PI is running the project and we structure the storage around the PI's projects typically.
Okay.
But that being said, it's all manual. So they have to manage their own data, and we just have worked with them on how to do that.
Same for us. It's manual. They choose where they want to write and store the files. I don't think there's an easy way to make automatic decision that would fit all the cases and move the data in the right place for everyone. So it's really manual so far.
Okay.
We're getting down to about 13 minutes left. So we probably have time for another question or two. Maybe three.
So you mentioned backups, Kevin, and I would ask, how does everyone deals with backups for the data? And do you pay for like expensive enterprise level systems, or do you just use tape libraries, or you just buy JBods and you have your own scripts to backup? How do you do it?
I guess I'll jump in first. So we have what I lovingly call janky JBot array that we use ZFS on top of. We're currently prototyping being able to use object store, and that can either plug into a central IT system or to the cloud. And so we're in negotiations with the central IT people about how we should proceed on that. And then there's also a central IT discussion about long-term storage, archival storage for research data. So I have my fingers crossed to be able to leverage some of that. But at the moment, it's just across the campus, another set of JBods. And that's project data and home, not Scratch. We flush Scratch every 90 days or so.
We're doing pretty much the same. And I'm sure everybody, like everybody, we constantly struggle with backups, and you know, it's just too much data. But we currently back up home and project to our own ZFS, and we don't back up Scratch.
At Cornell, we provide standard storage and then an archive service, which is not backed up. It's simply another copy of your data. It's only accessible via Globus Transfer or S3, and that's an additional copy. There's also a central IT provided backup service that provides like snapshots and things like that, but that's another paid service with Cornell Central.
So maybe to kind of take things a slight different direction, a question that Troy and I had kind of prepared a little bit is kind of, who is your liaison between your support centers and your owners at your site? And then kind of maybe the follow on is what you do to maintain those relationships or discover and build new relationships with possible new owners?
So for us, it's our support staff. Our support staff are our sales staff. They're kind of interchangeable because they're the people that are actually out there talking to faculty and talking to, in many cases, grad students who then go try to convince their faculty member to buy into a system to support the research that they're doing. And that's going fairly well. We do almost daily coffee hours these days, virtually, of course, now. Where we offer support and things like that. And a lot of sales contacts come out of those, people dropping by to get help with something or figure out what they can do. And it turns into, oh, we need to buy some stuff. But we also rely a lot on word of mouth from other faculty, telling other faculty members in the department, hey, this is how I do my thing. And we've also had a pretty good success getting into faculty interview sessions. So prospective faculty sometimes will meet with us so that we can pitch our services, because sometimes that's actually won over the faculty coming to this institution and not taking a different job offer, is the support that we're able to offer. So that's a big win too.
I'll jump in real quick. So at Rutgers, similar scenario, but there's a couple other prongs. One, since we support grants, there's a lot of top-end stuff where some researcher will talk to a buddy or to my boss or something. We have a business group so that if something does wind up on our side of the court, they can follow up and just run down all the questions they had, answer all the nitty-gritty stuff, figure out contracts or whatever somebody was curious about. Those people will run down. So shout out to Kristen who's on the call. Our tech people talk to other tech people. So shout out to Ryan and Bill on the call. Our frontline people, the refs, will often make suggestions or say, look, we can do this, but if you did that, we can do this other thing. And the other place that I would suggest people look into is that the folks who used to support the other clusters or the regional, in our sense, a campus-wide thing, if you talk to them, they're completely happy to move stuff out of their purview and dump it on your plate. So that's the other avenue we have.
I think
and Eric reminds me that we do actually have some lines in there, some hooks, if you will. So if large IT purchases get routed through certain channels, that kind of gets flagged and we get alerted to that so that we can step in and say, is this really something that you should be doing or should you talk to us?
For me, kind of to follow up on what Eric said about using distributed IT or using other technology, we created a monthly technical advisory group of all the different research IT people on campus who support at different levels, because we're very distributed. And so we meet monthly and just talk about things and issues and have little training sessions. But that's been really helpful for us because those are the people that are, sitting down the hall from the researcher that needs the help, and the distributed HPC admins have come too. So that is helpful. And then we also send a lot of stuff out to the graduate student listservs. And because they are the ones that, like you said, the graduate students are the ones that are telling their faculty what they need. So, and doing a lot of the work. So that's how we get a lot of our customers.
All right, what other questions from the attendees?
I mean, I've got another question. I'm just, have people seen any migrations towards more interactive analysis tools? Like we've seen a lot of people who want to use like Jupyter Hub and RStudio. I mean, we have a very like batch-based cluster with LSF, but it seems like we're getting more and more people who want some more interactive computing stuff. And just so like they want their desk, but writ large kind of thing. Like I need a terabyte of RAM to analyze this data set. Kind of thing, and we've done some of that stuff, but trying to figure out funding models for it. Of do we buy it? How do they pay for it, or whatnot? We've been building out of used equipment to just try and save money on some things.
So yes, to be snotty, just to not answer the full thing. So we set up essentially a couple of nodes to kind of handle some of that kind of ad hoc work. We definitely see it for people who don't have a pipeline yet for their work. Like they run it for a little bit, then they kind of look in and then see how the results are going and then tweak something. We see it for people who just are new. On-demand is very useful for that, and be able to plug in some of the functionality into that as well. So that's another path. And to be honest, I hear a lot more about some of the tools casually, just from discussion, than actual use. So we have, I won't call them vanity apps, but they're apps where they're definitely popular to talk about, but I don't see as heavy a use. And so that exists as well. And Jupyter Hub is in that category, but its use is increasing.
We offer Jupyter Hub, RStudio, on-demand, thin-link desktops. We offer all of these to all of our resources all the time.
Yeah, we're in the very early stages, but we're offering open on-demand, and we plan on expanding that over time.
Cool, thank you.
I also add really quick to that is that these kind of graphical interfaces, be it X11 or on-demand or something, are really almost a, pardon the metaphor, but a gateway drug. It makes it much easier to get somebody up to speed on why you might want to use the cluster. And then once they're there and they're kind of hooked, then you can start working on, well, you can get more done if you do this or that. So I think it's very useful to kind of bring in folks, since by definition, we're always going to have new users at our institutions, since graduates eventually escape and find something else to do.
How's the performance on some of that stuff? From like, if they want to need, we have a user wanted like a GPU app, and they want to control it from their desktop, especially remotely now that we're all doing home in the COVID era. How does some of those GUI apps perform, like especially if they had to do like a remote GPU kind of thing? Nobody?
No one's definitely.
I think it varies.
Good question, obviously.
Bueller? No.
It's not as great as using command line, but if it's, if they're comfortable with that, it's a path, right?
Yep.
And for us, that's where you want to get whoever's frontline support to kind of talk to them. So we do have a number of mechanisms where we're watching use. We do use our login nodes for some work that probably isn't optimal. And sometimes you have to kind of get somebody to go, hey, you shouldn't be doing this here. You can do it this way. And so that intervention and watching what's going on is a critical part. So essentially, there's a little bit of slop in the system so that new user can kind of get their sea legs. But if they're impeding somebody else, you essentially start slapping them.
Sounds like a good topic for a future call, interactive computing or interactive.
I would definitely be interested.
Yeah.
Yeah.
Good too.
It's pretty good in general with a cloud model. We also recommend people who have serious needs to use Amazon AppStream, which has been really successful. There's actually a video from a Cornell faculty member using like a SolidWorks modeling thing through AppStream. It blew my mind when I saw it as a remote access to scientific software.
Yeah, I'd looked at stuff like that. It was just the worry for some things is then do I need a big fat pipe from Amazon back to where I am to then, and then that's yet another cost thing there. Cause it's like, I got to do a VPN tunnel and so on and so forth. And then I've had people suggest that to me and I'm not against it, but the data's not there. And then I'm like, do I have to get it there? And so on.
All right, well, that brings us up close to our time limit here. I'd really like to appreciate all our panel sites and panel members for spending the time to prepare for this and to take the questions that have been asked, and for all those who have attended for participating and throwing the questions out and making this a meaningful and good discussion. Hopefully everybody found something that was valuable from today's conversation, but we will post the recording back to the YouTube channel. And we will verify with each of the presenters that it's okay for us to have the slides accessible out there. I think Rich was going to work on his that wasn't accessible. A few people had pointed out.
Yeah, that's fixed up. If people want to go back to those slides, they should be visible to everyone.
Thank you for hosting us.
Yep. Thanks, everybody. But otherwise, we will call it good.
See everyone soon.
Thank you. Thanks a lot, guys.
Thank you.
Bye.
Thank you.